All right, thanks everybody for joining us today. This is Rhett Glauser with SaltStack. You have joined the SaltStack webinar titled Devops Orchestration for Highly Regulated Windows and Linux Infrastructure. The majority of our presentation here today will be given by Jon Hathaway, who's the founder and CEO of HATech. And we appreciate his time, and we're looking forward to learning more about how they are using SaltStack and other tools and big ideas to do some pretty cool things on some pretty serious infrastructure and application environments. Just a couple of housekeeping items before we get started here. We are doing webinars really all the time, and we're looking for great content from our users and our partners. If you're interested in learning more about or seeing more of these webinars, just hit a couple of those URLs that we've got in the first bullet there. Hit our events page, look at our YouTube channel, and you can find dozens and dozens of similar pieces of content to learn more. As a reminder, the lines all will be muted to preserve audio quality. We welcome questions though, so please use the chat function in GoToMeeting, and we will get to as many questions as we can during our time here on the webinar today. And then we are recording this session as well. So whether you're on the session live or you weren't able to make it, we will be sending that recording to all registered attendees of the webinar probably within the day. So watch your email for that. Okay, just so everybody knows, this is not necessarily a getting started with SaltStack webinar or presentation. It does assume some knowledge of SaltStack, but you'll be able to learn and follow along no problem, assuming you know a couple things. One, SaltStack is a systems management platform. It does have a client-server architecture, and the Salt open source software is used for essentially four things. It's most well known for its configuration, automation, and management capabilities, but it was really built on a remote execution platform that is built for extremely high speed and to be able to address just massive scale if that's what you have. Salt Open also is excellent at controlling dozens of cloud environments, both public and private. And then, some of the unique things that you'll see with SaltStack, and I believe Jon will touch on today, is our ability to do event-driven orchestration, or in other words, to be able to have the system itself intelligently react to events and data. And so, if you're looking to learn more, Salt is open source software at its core. It's if you go to docs.saltstack.com, we've got great tutorials up there. We've got the downloads available for you. It's all right there, and it's very easy to get started. If you need us to help you with any of that, any of the process or kind of your journey to get started, just hit us up at info@saltstack.com, and we'll be sure to point you in the right direction there. So with that, that's all I've got to say. I'll get out of the way. I've introduced Jon already. I'm going to hand over the reins to him, and we'll get his slides up on the screen here, and we'll get started with the main part of this this webinar here. Let's see. There we go, Jon. You've got it, and your audio is on, so take it away.
Fantastic. Thank you very much, Rhett, for the introduction. Well, welcome everybody. So as Rhett mentioned, my name is Jon Hathaway. I am the founder and CEO of HATech.io. This presentation is really going to be about some of our journey that we have gone through over the last two and a half years. We were an early adopter of SaltStack, and we're going to cover off how we've been using SaltStack in a previous life, as well as what we've been doing with it recently. So just as a way of introduction, so we're a DevOps automation company based here in Las Vegas. We have presence both in the US as well as over in Europe. And we've been going since about November last year. Prior to that, every single one of us has worked in gaming in some capacity. I've got guys in the team here that have written core core layers in slot machines, from network connectivity all the way through to some of our back-end system engineering that many of the casinos here use in Las Vegas. And the purpose of this, a long time ago, about 4 years ago, I moved to Las Vegas with a very strong vision. I can't mention the company that I work for, but anyone who's got LinkedIn access will be able to go in there and see the history and the company that I originally worked for. And my remit was to build out the first cloud-based casino management system. And that was to serve both South America as well as to serve Europe. And there's a couple of regulatory reasons why we chose South America and why we chose Europe as we move through the presentation. But anyone who's worked in gaming understands there are a huge number of regulations. There are a huge number of jurisdictions around the world, each with their own rules, each with their own requirements. And one of the challenges you have when you start building out cloud-based anything in a restricted or a jurisdiction-driven application, the challenge you have is, how do you manage that access? How do you manage the capabilities? How do you manage what can and cannot be done in each one of those jurisdictions? And as you move through, we also had a number of internal challenges. Like a lot of organizations, we had jurisdiction challenges, but we also had a number of challenges that we were trying to deal with, both in the industry and from our customers. So one of our big challenges we had, like a lot of enterprise companies, we had lots of subject matter experts that needed to be sent to customer site to bring a system up and running. We had lots of staff turnover. Our average year or average number of years for hardware refresh in gaming in the US is somewhere between 7 and 10 years. And that gives us a unique challenge, because the chances are that the person who installed the casino's back-end system the first time round isn't the person that's still working for the company 10 years later. More importantly, because of the spread and the complexity of the software that we're going to be looking at, if we were to try and upgrade all of our customers, it would take us approximately 9 years just to upgrade one portion or one particular product line in the gaming industry. Well, if it takes us 9 years to upgrade, it also takes us about the same amount of time for us to roll out hotfixes. It takes us the same amount of time to roll out patches or anything to do with making that system more reliable. And that means the systems get out of date very, very quickly. And when you start architecting for compliance, there are a lot of things that we have to take into consideration. So not only do we have the problem with who can be deployed and when, but we have to make sure that certain capabilities in the application are only available in certain countries around the world. It gets even more complex than that when you start looking at Native American casinos and jurisdictions in the US. We're now on a state-by-state basis, or even sub-state a lot of the time. When working with some of the smaller jurisdictions, we now have to be able to control and manage what features, what functions, what capabilities are allowed within that particular jurisdiction. Then we start dealing with things like identifiable data. So we're now dealing with player data. When you put a slot machine, or when you put your card into a slot machine, it talks to a back-end system. That back-end system now knows who you are, where you're playing. So you now have other rules that now need to come into play around where data about that player is allowed to be stored. And now we're talking about a global solution. How do we make sure that particular player data stays within the boundaries of the jurisdictions that are allowed to maintain and keep a store of that data? And to make things even worse, it's a Windows-based deployment. And to compound that even more, we weren't allowed to make any changes to the Windows application as a whole. It had to be the same version of software we were running in our cloud-based deployments as we were running on-premise. And the reason behind that is it takes on average 6 to 18 months to have your software go through the relevant jurisdiction checks to make sure that it meets the requirements. the last thing you want to do is now have different versions of software that you now have to submit multiple times each and every time that you build or create a hotfix or create a patch. For those who are more in the Linux world, it's relatively easy to automate Linux. It's very easy to build configuration for Linux. In the Windows world, it's not so much a commonplace component of what we do day in, day out. The other problem we had is, well, we've got all these challenges with just getting the software out there. We've now got challenges with regards, how do we support the environment? How do we get people access? How do we scale our support teams? How do we reach into databases and do checks and make sure data is healthy? How do we do all this centrally, whereas traditionally we've been sending out huge numbers of teams around the world, going to sites day in, day out to manage the customers' environments and to do all of this manually. And when we look at deployments, what we wanted to be able to do is, well, if we've got all these teams deploying around the world, the chances of every single environment looking the same is highly unlikely. You know, we're talking thousands of installations for different casinos around the world, and different engineers put their slightly different mark on things. A lot of engineers will miss out certain pages of an installation guide. A lot of engineers will try and do things from memory. They've done it 100 times. 101 should be exactly the same as we've done before. And what ends up happening, this now compounds the support requirements, because now I don't have a consistent way to run, deploy, manage, and support these environments, and yet we're trying to do this all from a centralized location. And to compound that, in the US, we're not actually allowed to do what we were doing. There's regulations in place that prevent us. So our target market was Latin America. Well, as you can imagine, majority of the gaming companies are based in North America, not South America. So building a reliable system that could self-heal, that could be monitored, that had intrinsic logging was an absolute necessity, an absolute requirement for us to be able to build out a solution that we could centrally manage from North America. And if we look over in Europe, again, the issues change a little bit more. Paris, for example, is a particularly problematic area for gaming, where only certain changes to the system are allowed to be done by the French police, for example. They can't be done by a third-party operator. And this is one of those areas that I was referring to previously, where the same software running in different parts of the world has to have different capabilities empowered or turned on or turned off, depending upon the jurisdiction that you are working in. And again, the goal here was to have one version of software that was going to be able to work in all the different jurisdictions. And just as a visual aid, here is a very high-level diagram of just the challenges you have when running online gaming. Now, what we're referring to in this webinar is slot-based gaming, so actually physical slot machines in the casinos themselves. But when you look at what the requirement is around the world just for online gaming, you end up with some of these strange rules. So all the red countries, for example, online gaming is entirely banned, unless you're in particular states in the US. You'll see that the orange areas, just for online gaming, local casinos aren't allowed to operate online gaming, but if you're a foreign casino, you're allowed to. Then you can see on the yellow, for example, you have to have a license regardless. And then if you have, if you're the light green here, you can see that you only have to have a license if you're a local casino in that jurisdiction. And this is just for online gaming. For slot machine-based gaming, there's about 417 different sets of rules around the world for different jurisdictions that control what can and cannot be done. And when writing software and building systems, you have to be able to abide by all of those different jurisdictions. So we mentioned that we were looking at building cloud, and we also mentioned that we were building Windows-based applications, and we weren't actually allowed to change the application. We weren't allowed to make it a really cool .NET software as a service application, we had to be a little bit creative, and we needed to build this in the cloud that could be easily managed, maintained, and again, we didn't want to invest a huge amount of money in the infrastructure. We really wanted the infrastructure to grow. Now, for obvious reasons, I can't use AWS, I can't use SoftLayer, I can't use DigitalOcean, so we ended up having to build our own requirement. But as we went through the tools evaluation, what was really critical for us is we wanted to make sure that we picked a set of tools that would grow with us. That meant that it had to be able to be adopted within enterprises. It had to have a following. It had to be going in the right direction. It had to be able to support a number of operating systems, because even though we are Windows now, we knew that we were going to be Linux and specifically Ubuntu in the future. And we also knew that as regulations are going to change and we're going to be able to and be allowed to do more with public cloud, we wanted to make sure that we picked a tool set that wasn't tied to a specific type or a specific platform. And that gave us the flexibility to be able to write recipes and states in Salt that we knew were going to be able to be utilized across different components. And this is what we ended up with in our first parse. It was a Mirantis OpenStack environment. And you can see here that you've got many different casinos connecting via VPN into the data center environment. We had the typical OpenStack based architecture. We were using Ceph for storage. We were using Zen for our hypervisor. And we had these three support services on the right-hand side. So anyone who's used Mirantis OpenStack, you have a Fuel server, which is responsible for deploying and managing your OpenStack environment. We had Zabbix as our monitoring platform, so we were continually gathering statistics, both from the OpenStack environment, but also the Windows VMs that were running on top of that OpenStack environment. And then we had our SaltStack master. And that Salt master had two jobs. It was responsible as the data authority for that particular data center, and the OpenStack environment at the time didn't have any native SaltStack support. Fuel itself at the time used Puppet to drive the configuration management. And one of the challenges we had is we originally tried to use Puppet, and we originally were going to use Puppet to do everything because it already came with the Mirantis OpenStack solution. And what we found very quickly is while Puppet may be very popular, it's not the easiest solution for operators to learn from the ground up. If you're taking new junior operators and you need to empower them to be able to write recipes and be able to manage configuration, the Puppet solution became a little bit too difficult because of some of the ways that it's architected to get people's minds around it. We also needed to make sure we had a solution that worked on Windows. And at the time, Puppet and things like mcollective that we wanted to use for dynamic inventory weren't available to us in a stable enough capacity 2.5 or maybe 3 years ago. So we ended up using SaltStack, and just to give everybody an idea of how quickly we adopted this from a proof of concept, we spent about 3 weeks working with Puppet, getting it working on Windows, getting mcollective and the rules and the certificates and the recipes working. We managed to do the same thing in about 30 minutes with SaltStack. And so based upon that, being an open source, having an open source background, one of the things you're looking for is how easy it is to adopt new technology without this steep learning curve. And so we really went from battling with Puppet to immediately adding value in the organization we were working for within 30 minutes. And that's been our experience the whole way through with SaltStack. And we'll look at some of the more advanced things that we were doing. But the idea here is that SaltStack not only was adding additional information to the OpenStack environment, it really became our command and control mechanism for our VMs. In a highly regulated environment, there's things that I need to be able to do. And SaltStack gave me the ability through role-based access control to be able to control very granularly what states and what capabilities each one of my support staff were able to do. So I might have to grant a user access to do a specific capability. That was all managed through role-based access control and managed through SaltStack. SaltStack. Now, there is a caveat there. We did write a lot of state modules ourselves for our solution. And when you write the state modules, it becomes a lot easier to manage the role-based access control mechanism, because you can have a whitelist of what they're enabled and what they're allowed to run within the environment. But it became a very clean and very repeatable manner. Even in support, having the same way that I diagnose, having the same way of being able to run network checks from inside an environment, and then utilizing that information and adding it to a support ticket all automatically enabled us to run the entire environments with 3 people 24/7 out of North America. We never ever had anyone over in Europe. Everything was done remotely. So why do we still choose SaltStack? Well, we mentioned one of the use cases, which Puppet just at the time wasn't the right solution for us. But we really wanted to get to this event-driven behavior. My background has always been involved in cloud or in support and operations. I've worked for Computer Associates as lead architect, as well as Rackspace as their solutions architect over in Europe. And if you're going to scale a team, one of the core tenets you have to look at is, how am I going to scale support, management, and operations? The deployment is relatively easy, but the ongoing management of the customer, how can I get that information and create intelligent flows that enable me to scale the capabilities within my team, is absolutely the top of our list. We also wanted to be able to orchestrate complex behaviors. So it's not as simple as I want to spin up a VM and I want to install Active Directory. In the gaming world, we had a lot of things that had to be done to a certificate authority that enabled certificates, revocation of certificates to occur, because every slot machine traffic communication is encrypted through SSL in this environment, and being able to securely accept and manage those SSL certificates meant that the certificate authority was the most important component of our setup. The certificate authority also became the most problematic when environments were manually installed. There were a lot of changes, a lot of policies that needed to be built. And what we found, just by moving to SaltStack to deploy just the certificate authority, not just in cloud, but on premise, we could reduce the number of visits that we had to customer site by 50%. The majority of large casino floors that failed to come up and meet their release deadlines, the opening times, were caused typically by misconfigurations in something as complex as setting up all of the complex rules that we had to put in place for the different regulations in the certificate authority. And then we go through other things that were very useful for us. So being able to query the inventory at any point in time, getting a complete view of what was installed, what Windows packages. Lots of us come from the IT management world, where you want to create reports of what's installed and where. We were able to do that with a single tool set without deviating from our core goal. The Windows support at the time was by far the most mature out of all of the different configuration management tools that we were playing with. And then we got the event-driven configuration as well, which became it even more valuable to us. And for us, we found that Python had a far cleaner footprint on our Windows servers than Ruby did. It was a little bit more reliable for us to be deployed. And so writing state files and writing add-ons and plugins from a Python perspective, again, was a little bit easier for people to be able to grow and adopt. And as everyone's seen, the community, the number of plugins and modules has grown exponentially within the SaltStack community as a whole. So as Rhett mentioned at the beginning, one of the core components that we wanted to really tap into when we were building out the SaltStack environment was we really wanted to be able to capture events. Now, if anyone was building OpenStack 2.5, 3 years ago, there were a number of challenges with OpenStack with regards to RabbitMQ, with regards to storage layers and storage mechanisms. And there were well-known patterns that we were building and working with Mirantis at the time that enabled us to come up with a very clean runbook of how to deal with these events when they occurred. So, for example, Rabbit would have issues with queues disappearing, the persistence for the queues didn't work as expected, the clustering on the OpenStack environment, sometimes nodes would disappear. Originally, there was no full ability for OpenStack in the queues. And so what we ended up doing is, once we built out these manual processes, we actually turned them into orchestrate orchestrated driven support processes. What this meant is I didn't want to add another 10 people to my organization just to train them up in being OpenStack specialists. I've already got my OpenStack SMEs, and what I wanted to be able to do was take that pattern, take that event, I know how to fix it, and then what I wanted to be able to do is then drive that orchestration every time I saw that event occur. And that might include sending a message to chat, that might include them running through a very specific and ordered list of resolutions from end to end, and then also using the orchestrate function to then validate what had been deployed and what had been resolved actually met the requirements. We had the same challenges with Ceph. Now, Ceph, when it starts filling up with data, becomes harder and harder to manage. You need to move data around. But that moving the data around, we had a very well-defined process and algorithm so that whenever we saw an event coming from Ceph, and that could come through monitoring, that could have come directly through the SaltStack minion running on the Ceph node, we were immediately able to carry out some remediation that enabled us to prevent a catastrophic failure. And when you look at this is all being done with a team of 3 individuals, we spent more of our time writing events and orchestrations than we actually did ever supporting the environment. So what about SaltStack in gaming? Well, we've seen how we were using SaltStack from an OpenStack perspective. SaltStack from gaming was slightly different. What we wanted to be able to do is, based upon some of the regulatory challenges that are out there, we wanted to be able to carry out certain events because our reporting requirements might be different. So the Windows application itself would log all of the events from an application perspective, so anything from a .NET application. Because of the jurisdictions we were working in, it was part of the requirement for the software to be able to log that. But what about things like the OpenStack environment? What about people restarting services? And what we ended up building was the mechanism to watch for people logging into the environment and then carrying out a mechanism. And that might be writing a task to a database, writing a task or sending an email under certain circumstances depending on that jurisdiction. And even though there's many other tools that do that, what we were trying to do from a security perspective is keep our footprint as small as possible. Same with restarting services. If something restarts at 2 o'clock in the morning, we really should have a look at why that occurred. And so if we saw a service restart, we would create an event, we would create a ticket for follow-up, and then we would have a remediation process that would go through that would then go and check other key components of the infrastructure to see if they were still healthy. If any of those failed for any reason, then that would immediately get escalated. If we found that they were actually healthy, then we could actually automatically close the ticket itself. The other interesting thing that people may not be aware of is a slot machine really is nothing more than a desktop PC with many screens and different displays added to it, and then buttons that replace the keyboard and mouse. And so in the management tool that we were using, we were able to push out content onto the individual slot machines themselves, so you could change the theme. You could, much like playing a Nintendo, you have your Nintendo and you have your television, but you can change the games themselves running on that machine by just pushing out new code into that environment. But that means that the slot machines themselves, they have this life cycle. They have to come online, they have to correctly authenticate, and then during the process, what we're interested in is when they go offline, or they disappear, or they continually reconnect. And we were able to look at the logs and create SaltStack events that enabled us to see the health of that slot machine. Now, the Windows software would track that itself. But what's more important is, from an operations perspective, those operators didn't have access to that eventing information. And so we started building other eventing and other mechanisms that enabled us to audit at a very, very low level all of the health of everything related from the slot machine all the way back to the system. So we were building audit logs and availability logs, and we're using SaltStack to actually be the mechanism that would drive that information and create that entry in the audit report itself. So some of the processes we went through, again, this may be new to people, it may not be new to people, but I thought it would be interesting for you guys to see how we actually defined the different roles. So using OpenStack, similar to many EC2 compliant based platforms, you have this mechanism of creating a virtual machine and you can pass in user data. That user data is a script or some specially formatted payload, and we were using that mechanism to set the salt grains in the virtual machine. When the virtual machine then was booted up and spoke to SaltStack, SaltStack was able to grab all those grains, and by using pillar data and using some eventing, we're able to then manage bringing online a particular system. We also had to bring the system online in a very specific order. And so we were using things like events and grains to record the run level time of the application. So we were able to update the grains, and in there we would put the status of how far we were or what component needed to be started next, and then we could use the high states to then kick off the events to be able to drive the next layer of the orchestration. So we had a very, very strict, very rigid deployment pattern that was very, very easy to maintain, but very easy to control the dependencies, because we were using eventing and orchestration for some of the more complicated components. One of the byproducts we found by moving to SaltStack and taking this approach using roles, grains, and events is it made adopting DevOps a lot simpler and a lot more aggressive. So our approach at building DevOps is we built a true DevOps culture. So we took people from Ops, IT, product management, engineering. We carved out an area in the office where everybody sat together. We ate lunch together, we went to breakfast together, we had a very tight group of individuals, but we all had our separate reporting lines, but we were all working towards having this single DevOps vision of getting this software deployed very, very quickly. And what's interesting and what helped from a DevOps perspective, because we were using roles and eventing, it enabled us to have a very clean separation through the release process, not just for our software that we were deploying, but also in a regulated environment of how things get into staging in production can change which roles can live on which servers and what that combination can actually look like. So from a development environment, well, we don't really care. We had one VM that had all of the roles installed on it. So it would have SQL, it'd have AD, certificate authorities, the .NET, communication services, everything would be wrapped up into a single dev instance. Integration, well, we wanted to be able to do some testing, and so we wanted to be able to put functional tests through the environment. So we scaled the environment just enough to be able to carry out the testing that we wanted to be able to do. And then for staging and production, typically for the majority of jurisdictions, I had a one-to-one mapping. I had to have one role on one VM. What was interesting is this was one single recipe that did all of these environments for us end to end. The jurisdiction requirements were built into the pillar data and were built into the eventing and orchestration templates, but it enabled me to have one single pipeline for my SaltStack infrastructure that enabled me to manage all of those individual environments and keep the footprint as small as possible. It also facilitated us moving from CI all the way through to continual deployment. This was kind of an accidental achievement, but we found very, very quickly that just using high state events and orchestrations, we could see a check-in into Git, go build the package, and use a SaltStack event to go and deploy that using a high state without having to use any other tools. Remember, this is pre-Docker, and this was Windows. And so we were using very similar patterns that you see now in the Docker build processes and some of those other mechanisms that are out there. We were using SaltStack to watch Git repos and be able to drive deployments through the eventing mechanism. And again, through simple recipes and some clever data and modules, we were able to have single recipes that would enable us to go all the way from CI through to CD, and we're using Jenkins and SaltStack together to be able to manage how that gets built. We use Jenkins extensively using the Salt API plugins so that Jenkins itself could go and trigger particular high states or carry out commands on the environment as and when necessary. So just to finish up, and I really appreciate everyone's time and attention. So where did we end up? Well, remember our goals was we had support issues, we had deployment issues, and we had patching and upgrade issues. So where we ended up very simply is we ended up with identical solutions. Again, we were able to run this with 3 individuals supporting 3,000 slot machines around the world, something like 30 different casinos, all using their own different jurisdiction-specific settings. But we were able to do this because all the environments looked identical. We used a lot of SaltStack role-based access control and our own state modules to control what the different people in different jurisdictions were allowed to do. We had an audit trail of every single change ever made to the system, and one of the byproducts or one of the requirements is we had to remove the day-to-day remote access logins to Windows to make this work. So we actually removed the main administration privileges from the Windows machines themselves. Effectively, they were completely headless. There was no way to manage our Windows environment other than by using SaltStack. We could get an inventory at any point in time of what was installed, when it was upgraded, just by querying the infrastructure. We managed to reduce our deployment time from 120 hours down to 90 minutes. And a lot of that was because we didn't have to send specifically skilled or licensed individuals to the specific jurisdictions around the world. We had no requirements for us to go onto site moving forwards. We changed the system upgrade requirements. Normally it would be about 18 months to schedule having someone go out to site. We could schedule an upgrade in less than 2 weeks. 2 weeks is our absolute maximum. So as soon as a patch and a hotfix had been released, using the jurisdiction rules, we knew what SaltStack recipes or what packages were allowed to be deployed into which jurisdiction, and that became a very, very automated process. We managed to do all of this and turn it into a cloud application and build the eventing and orchestration model without changing any of the .NET application at all. Instead of building a true SaaS, we actually built a single tenant based model, so every customer got their own instance of the software. But we managed to do that in such a way that enabled us to build out that application so it looked and felt exactly the same whether it was installed on-premise or whether it is installed in a cloud environment. And most importantly, hotfixes. Hotfixes in the casino industry typically are hotfixes that affect the ability for the casino to take money from the floor, and therefore it was really important for us that we could get hotfixes out there as quickly as possible. And we were able, from the time that we scheduled the hotfix with the customer to deployment, we were able to push out that hotfix. But a lot of casinos had many different properties, and so we could arrange it once with that customer, agree that we're going to upgrade all of their systems, and we would batch together all of their deployments all at the same time. And again, all this was driven through eventing and some orchestration that we built into SaltStack. So that comes to the end of where we were and what we've been doing. And my email address is here if anyone wants to follow up and have any questions or wants to do a further deep dive into any particular area that we covered off in this webinar.
All right, John, thank you very much. That was fascinating. I have a new respect for the casino floor now, and we'll never look at it the same way. So let's if there are any questions, like I said, please enter them into the chat function and GoToMeeting. At this point, we have not had any questions, so we'll give you just a couple minutes here to get those in. Let's see. So John, can you elaborate a little bit more on how you are managing the team in terms of like the role-based access controls in your environment, and I guess Salt specifically? Obviously, in a highly regulated environment like this, I'm sure that's important. And do you have kind of audit visibility over who's doing what work and jobs and stuff like that?
Yeah, absolutely. I mean, this is prior to some of the other audit tools that are out there that many use now with regards to SaltStack. But at the time, one of the things we were doing is we were bolting and changing the SaltStack environment. So instead of using the local PAM login module, then what we eventually ended up with is the ability to pull from Active Directory. And Active Directory then set the permissions and gave SaltStack the information of what they're allowed to run and when. As I mentioned before, we actually built state modules that were able to be filtered and very uniquely controlled. And so instead of building a salt module that maybe had 20 different kinds of methods, we actually built the salt modules in such a way that they were grouped together by jurisdiction. And so if you had someone that had a UK gaming license and they needed to make a change, they would be in the UK gaming license group, and they would only be able to access the state modules for a UK jurisdiction.
Got it. Okay. So I think that first question also kind of opened the floodgates for more questions. I don't know, John, if you see in the chat function there in GoToMeeting those questions, or would you like me to read some of those off?
No, I'll start from the top
Yeah.
down.
Yeah. Good.
So the question regarding Jenkins, and so a lot of organizations, when we're building software, we have to build those packages. SaltStack itself doesn't build application packages. It can control any command, but it doesn't have the necessary typical workflows. And so the process would normally be someone would build or write code. That code then needs to be turned into an MSI exec application. But then it also needs to be tested in a development environment on a particular infrastructure, and then be tested in integration, and then be tested eventually in staging and production. Jenkins is the typical tool that many of us use, and it's very similar to things like Team Foundation Server from Microsoft, or if someone's familiar with Travis or Circle CI. They're really packages or tools that enable you to execute something, run a test, and get a response. And what we were doing with Jenkins and SaltStack is using Jenkins to trigger Salt events as part of that build process. So Salt knew how to build the environment, and we would use Jenkins when we saw a new package being built or released. What we would do is we would trigger a new infrastructure deployment in SaltStack, and then SaltStack would then deploy that package into that environment. So the two lived very closely together. One was watching the development environment and the development processes, and SaltStack was watching the operations and the automation processes. Okay, so next question: how are you bootstrapping your Windows boxes? So we were actually using Cloud Init, which is a tool that comes with the majority of Windows VMs. So if you go and get an authorized Windows VM, so Cloud Init is a tool that comes from Cloudbase, and it sits on the Windows host itself. And what you end up doing is when the VM starts up, a lot of the cloud environments actually have what we call the magic IP address. It's a specific address, which is 169.254.169.254. That address has metadata, and you can add information to that metadata. And what happens, the boot process looks like this. You spin up your Windows VM goes and reaches out to that IP address and asks if there's any scripts that it needs to run. Those scripts then are how we were installing Salt. And so it would be a PowerShell script that would go in, it would install Salt, it would create the Salt configurations, we would inject into that where Salt Master was, and so the VM would come up completely hands-free. All we were doing was changing the user data that was being passed into that VM. So there was a tool called Cloud Init from Cloudbase, and it works pretty much with the majority of clouds out there. If you're working on a cloud that doesn't have the IP address, then you can actually get around that by using a floppy disk and putting the script on there as you boot the VM. Okay, so next question. Do you control the complete build of Windows servers from boot on customer premises using Salt? So we actually have a base image. Salt actually kicks off an installation or a build process every night. And we use the unattended mechanisms to build out a base VM. That base VM then becomes our authorized VM for a period of time. When we do that deployment, what ends up happening is that base VM knows how to bootstrap. Similar to the previous question. For some customers, we have to hard code that. So we might have a bootstrap mechanism in there that works for the customer. So we've worked with customers before that when a Windows machine boots up, we may reach into one of their file systems and we'll pull out maybe some configuration data that enables them to find the salt master, if you like. But we were always building packages. So we never built true VMs in the sort of the sense of the world where people are building the OS, adding the applications, and then releasing the VMs. We were always doing package-based deployments. And the reason we did that is because it's a cloud environment, we didn't want to start shipping around 20 gig Windows images with all the packages and everything else. We also weren't allowed from a jurisdiction perspective to do that. We weren't allowed to ship certain content across borders. We had to build it in that jurisdiction. And so really we were always doing a base image, which basically included our tool set, and then we're always adding the application in real time during the deployment process. So it was always a clean deployment end to end, and we sort of escaped the need of having to build different VMs for the 417 different jurisdictions around the world. Okay, did you have to include elasticity infrastructure, and how did you achieve that? Well, we were using OpenStack, and so what we basically had is we had an event in the OpenStack environment where we would look at how many slot machines were connected to the infrastructure, and so the particular application we were using could communicate with 200 slot machines at any point in time. As soon as it got to a multiple of 200 or more, we had to start adding a different communication servers. And we actually used salt events to do that. We also used salt events to spin up the new VM, add it to the domain, bring it up online, add all the packages, but then we also used Salt to then dynamically set up the load balancer. And so we had a very specific load balancing configuration because of the SSL and because of some state that is required to understand how the slot machine works. What ended up happening is we had to be able to pin a particular slot machine to a particular communication server. And we actually used SaltStack events to be able to manage that configuration and that onboarding.
All right, John, I think that does it. I think thank you for answering those questions from the audience. I don't see any more coming in at this point, and so again, great presentation. Let's see. One last question. Oh, no question. Just had somebody come in and say this was an excellent webinar, and thank you, John. Echoing my sentiment. Yeah, very good presentation here. Really appreciate the work you've done and that you're willing to share it with us. If anybody has any other questions, you've got John's email address right there on the screen. Feel free to reach out to him. If you got questions for SaltStack, just hit us up at info@saltstack.com. There's a bunch of other ways to find us. We thank everybody for attending today. Like I said, we'll get this recording of this webinar to you very soon. So watch for that in your email if you'd like to share it with your team or other folks. And we'll close it with that. Thanks again, John. Thanks, everybody.
It's a pleasure. Thanks very much, everyone.